As Ryan had mentioned, we're going to talk about AltaView. It is our graphical user interface for setup and control of our 1553 and other modules and devices. In this instance, we're going to cover the basic layout of the GUI. We're going to talk about 1553 channel devices versus our global device controls. We're going to talk about user setup of 1553, including bus monitor, remote terminals, bus controller, and last but not least, recording and playing back of 1553. So to start off, when you first click on the AltaView icon on your desktop, it looks very much like this little logo you see right here. You go ahead and launch what I call the home screen or the main view. Okay, and this is basically the focal point of your interaction with AltaView, and it's the point at which everything sort of starts and stops, if you will. So a couple things to keep in mind, that the little Alta logo button is used for opening devices, loading setup files, and things of that nature. There's also shortcuts for the same type of thing that allow you to open files, make your savings, your setups persist, and so forth. Now you'll see up here, there's 3 tabs. There's 1553, A429, and Global. We'll be talking about 1553 and Global today, but this is basically the tab that you click on to interact with and control the specific device that you want to work with. You'll see here in the larger circled area is the device panel menus, and this is where you get a little more specific. So for 1553, you're going to have a bus monitor control, you're going to have an RT control, and a bus controller control. Okay, and we'll go into more detail on that as we continue. And then the next order is the AltaView PDF selection. So something to keep in mind is the user's manual is actually loaded with the application so that you can access it while you're operating the software, along with the MIL Standard 1553 handbook for 1553A and also B version of 1553. So they're just nice reference documents in case you have a question. And then last but not least on this page is the master run, stop, and start controls here, as well as version help. So that's always nice to know what version of the software you're running. So if you need to access that, it's just a little blue button with a question mark in the middle of it. Okay, so as promised, we've got the open device button here, and we have clicked on that. And what you see here is this next little dialog screen. And what happens is the system software actually goes out and interrogates the computer to find out what Alta card might be plugged in to the backplane. And in this instance, it's discovered that we've got a PCM-CIA board, or rather a PMC board plugged in. Excuse me, let me go back up. Okay, so it's taken that inventory and it's showing, hey, we've got this board and here are the 1553 channels. We've got a second board, with another type of board, a PMC MA4 board. Here's a PMC 1553 board, and then the various channels that they've got. So what we want to do is simply select the device or the board and the channel that we want to program at that time. And then you'll see that information would be displayed over here. And I'll show you a little more of a meaningful presentation when we go into the live software. Okay, some other things to keep in mind here are some additional functions, if you will. 1553 options, usernames. You can actually assign your own unique username to 1553 remote terminals and sub-addresses and so forth. And you could also set your time options, okay, for the internal time using the system clock, or external time using arinc time, external source. Okay, and so once we've clicked on the device, it goes out and the system will go out and basically run a bit and a series of tests to verify the proper operation, and then it'll notify you of that. Okay, so the first thing we would do is notice that we can click on the bus monitor control, and this is probably the most popular screen that you're in, because this is the one where you can see all the status of the traffic, the 1553 messages, and so forth. So here, automatically, we see this color-coded display of the status of the 1553 bus and the remote terminals and the messages. Green obviously indicates things are good, and red indicates things are not so good and attention's required. There's also yellow, which says there was a problem, but it's not a critical one. Okay, so we can go into that more. But the nice thing is you get all of this instant status without programming a single thing. Everything that appears on this bus monitor control is provided for you. Okay, you don't have to program in order to see this information. That includes over here with the snapshot viewer. Okay, and what that's going to do is it's going to show you specific messages and in fact show you the data. And then if there was to be an error, it would indicate there was a no response error or a parity error or something of that nature. All right, so you get all of that information instantaneously. All right, some more features of the bus monitor. Here's our signal viewer. Alta and AltaView are the only supplier of 1553 test and simulation boards and products that feature this signal viewer. And basically, it's an A to D on the first channel of the 1553 card or device that shows you the actual waveform of the 1553 traffic. So it's just a very nice, quick way to get assurance that you have a normally shaped waveform. You can see in this case, it's a command word starting high and then going low. So it's a good, clean transition. And then your message traffic following. So one would be confident in their 1553 bus signal looking at this particular display. Other thing is called the data table. Okay, so you can actually take raw hex values or octal words off the 1553 bus and convert them to whatever unit of measure and value that you like and display them. So you can do your EU conversions in this table. Very nice. And then say I want to go down here and understand why this subaddress 1 here on RT6 was red. Okay, I'd go and double click or right click on this right here, and it would pop up this little dialog. It would show I've got a parity error. Okay, so that's the problem. So I would have to go and address this this whole issue here to resolve and eventually turn that into a green light. And you'll see the red status sort of tracks all the way up here to the bus A and then to that channel 1. That this is what's causing it down here, is causing the status to read red up top here. Okay, so we've just covered bus monitor. Now we're going to cover remote terminal control panel. So as it says, very easy, consistent way to display status and auto detect controls and so forth. It's basically, this is where you go ahead and define any remote terminals that you want to simulate. Okay, so you would just go ahead and click on the channel that you want to work with and then start adding remote terminals. Okay, and then you would in turn go ahead and start adding sub-addresses and then editing the various attributes of those sub-addresses. And you'd create buffers, transmit buffers, okay, and you could specify the data, whether it's incrementing or whether it's random or whether it's unique or what have you. Okay, and you'll notice on all of our controls, let me go back up one here, you're going to see a start and stop button. So here's the stop bus monitor because it's running, so we want to stop it. Here, the RTs are not running, so I would want to start them. Basically, it just changes from start to stop depending on what phase you're in or what state you're in. Okay, and again, we'll go into a little more detail when we actually go into the live demo. Now here we've moved over to the bus control. So you'll see again, here is basically the schedule, the message list of all the things that the bus controller is orchestrating on the 1553 bus. So these are the buffers that it's sending, to and from the various remote terminals, and the different type of messages and so forth. So you can go ahead and start clicking away and adding, a BC to RT message, or an RT to BC message, or RT to RT, what have you, even a mode code. Okay, and that starts populating here on the left-hand side, and then you'd go in and edit the buffers to specify the contents of those messages. Another thing to keep in mind is all setup data is stored as an ASCII XML file. So first of all, it's easy to read, and secondly, it's easy to maintain. And you can, if you've got an ICD or interface control document, you can actually easily import that as well. Okay, so playback. Okay, let's just go back up here on the bus monitor again. You'll see here a thing called archive settings on the bus monitor. So if I stop the bus controller, these would actually become bold, which means everything would be active. And I can enable archiving, and I can create a file name and a location to store, and a file size even. Okay, so when we go down to the playback controls, we would be able to click on this right here and then go access that file that we had recorded, okay, and then start playing it back and viewing it on the screen, or even outputting it over the 1553 wire itself. Very nice feature of this playback capability, so you can turn on and off the remote terminals who you want to see the messages from. So that's a very useful feature. A lot of people will go ahead and actually record live data and then use the playback data for simulations. Okay, so just to quickly summarize, AltaView really is the latest generation of analyzer. No one's developed anything since we developed it back in 2009. Okay, it's featuring all the latest and greatest technologies, including the .NET and ribbon bar GUI technologies. It's based on an XML setup and schema, so it's easy to edit. And as I mentioned before, import ICD information. It's easy to use with the GUI. It's very self-explanatory. Doesn't require a lot of training. You don't really get lost in Windows either. You get back to that main view very easily. Okay. The signal capture and the EU data conversion are built in. They're not add-ons that you have to pay for. And then you can load AltaView on virtually all of your computers for free of charge. Okay, there's no per license fee for loading AltaView. The only license, if you will, or payment for AltaView that you would encounter is to enable the full functionality of the software on your card or device, in which case kind of turns that card or device into a hardware key, if you will, to activate or unlock those advanced features of AltaView. So that kind of concludes the summary part of the AltaView. What I'm going to do is show you the setup that I have here in the office as far as my computer. So I'm running my laptop with AltaView. I've got our T-Bolt, which is a Thunderbolt interface to 1553. So I've got both bus A, or rather channel 1 and channel 2 operating. So I'm able to do loop backs and so forth between different buses. Okay, so how we start AltaView is very simply just going to the desktop, double-clicking the icon, and there, as promised, is the main view or the AltaView main application. So what I want to do is I'll plug in my device. Probably heard that. So that's the Thunderbolt going in. And I plugged in my device. Now I'm going to go up to the icon button, click on search for device. And right now the software is going out and interrogating the system to see what's plugged in. And it's found a T-Bolt. This is a multifunction device, does both 1553 and arinc 429. Shows you the serial number, and then it shows you here some information about the product. It's a full function device. It's got variable voltage option installed. It's also got the RT validation software installed, and the full version of AltaView is enabled. So that's the AV. All right, so basically this device is fully loaded. So I'm going to click on channel 1 here, and that's going to be what we're going to work with right now. And you'll notice over here on the right-hand side that the software followed me. I went and clicked on the T-Bolt MA4 channel 1. It's the board or device number 1 and channel 1. Okay, so it's just confirming that information. So I'll go ahead and just click OK. And got good information right here. It says we've initialized successfully and run the PBIT, and it's passed. So this red that you see here actually corresponds to channel 1 on the device. If I was to go back up here and repeat the process and click on channel 2, that stripe would turn green on the new one. So you see right there, we always color code channel 1's red, channel 2 is green. I don't know what other channels or what other colors, but that's basically how it looks. Okay, so, and in fact, that one's passed and initialized, so everything's happy. We want to again look at the little green here, the little blue bubble here and question mark, and it's going to give us device information. It's going to confirm the product we're using, the serial number, and the very voltage. It's just a nice little feature to know if you have any questions or you get somebody new on the team that wants to know what you can do with this device. So enough about this specific device. We want to just go ahead and look at the 1553 options and click on that. And basically, it's just some kind of administrative setups for your protocol options and trigger control. Okay. There's also the usernames that I mentioned before. So you could say, hey, I'm going to go take RT10 and I'm going to give it, a name, and boom, then so RT10 is going to have a little label like that, what have you. You can also label your bus A, bus B, whatever you want to or might need to. Again, information like this is usually contained in your ICD, and it's nice to know that you can actually utilize that information to program the card or the system. Time options. Okay, we're using the internal clock, the external clock, raw, iRig. Again, it's very self-explanatory. Just point and click. All right, so let's go over to the bus monitor controls. Okay, first of all, before we start up anything, we actually have to open the bus monitor control. And right now, if I was to hit start, we'd see nothing because we're not doing any simulation and we're not connected to anything. Okay, so we'll just stop that. what I'm going to do right now at this point is actually go and open up a configuration. So I've got all these guys here. I think I'll just take this one here and select this guy. And I'm going to go ahead to the start all. Okay, so we've got a lot of information, a lot of things going on the screen right now. So the first thing to note is the signal viewer. Okay, now I've got 1553 signal viewer bus A coming from the T-bolt board 1 channel 1. Down here I've got 1553 signal viewer bus B on the T-bolt MA4 board 1 channel 1. Okay, so just simply bus A, bus B. But looking at all of it, it actually looks okay. I mean, not horrible. We do see some red lights over here on the bus monitor status, so we know it's not perfect, but it's a reasonable looking 1553 signal. Okay, so let me just bring this over for your attention here. And what we're going to do is just simply observe what's going on here. First of all, we see some yellow, and we see some red, we see some green. So it's kind of like everything's presented. As I mentioned before, the very top level is going to show red because in a subordinate level, there is an error. So let's double click on this guy and see what it says. Okay, so here is the current value status, and we see time, and we see message. All these values are incrementing. But mainly, we're looking at bus A is a command message, RT2 to receive at subaddress 1, 32 data words. It's a BC to RT message. And we see down here all zeros. And we actually see a bang, an exclamation point here. So we see there's a problem, and we looked at it. That's what that. So we would have to go in and look at the setup for that RT and correct that in order to change that status. Okay, so we see over here as well. Let's double click that, and we'll get some status. And here we don't have a parity error, but we do have a no response error. Okay, and that's again an RT to BC message. Okay, now everything I've been showing you so far has not required any programming. This is all information that's provided passively, if you will, or without any user programming. Okay, to create this tree right here required nothing more than simply running the bus monitor. Okay, to start these guys up required nothing more for the signal viewer than to click on the image, go ahead and do something that's going to convert it from raw to an engineering unit converted value. You know, a data table, a button, and then start. Oh, that was weird. A little feedback there. Anyhow, but you can see the different types of data conversion are provided here, whether it's numeric, binary coded, or IEEE floating point, or no conversion, you know, what have you. Okay. But very nice little feature, and you can save all of this as I have done. Save it all as a file name to recall for future use. Okay, so let's look at the RT control for a moment. Let's click on that, and we'll see we've got the RTs running. Let's stop the RTs right now, and we'll see that we can add RTs. So let's go ahead and add an RT here. Okay, we can click on this RT, and we can add a subaddress. Maybe, have you. We can click on that buffer, and we can go down and edit that buffer, and we can just say, let's put in random data. Okay, and now all of a sudden we've got, an RT defined, and we could start running it, and then we could go in and add it to the bus controller list, so that, remember, when you're doing RTs, it's a command response bus, so the bus controller has to be involved with regard to telling that RT that it's receiving this buffer. But the basic idea is that you can very easily interact with the card or device and program it on the fly, and then, start it up, stop it, what have you. Let's go over to the bus control icon right here, and we can go ahead and stop that guy, and we could go in and edit this, add a BC RT. You could go back in and select the RT that you want to create. Let's stop everything. Okay, and then let's go to the playback control and browse to a recording. Let's just see what we can get here. And start playback. Now we'll do repetitive. And we can see down here, the playback is occurring. Values are changing. I haven't started these guys. Okay, I've got nothing happening on bus B here. And I can increase the amplitude on my bus A. So I'm just looping back this playback. But that's all there is to it. Very simple. I can stop that, and I can just go back to everything's live again. Decrease that amplitude here. There you go. So that's basically, in a nutshell, a very quick overview of AltaView and what it can do and how you interact with it to accomplish that. Okay, one last thing I want to show you is the notion of the global controls. A lot of people don't understand what that means, but it's basically where you perform some more administrative type functions like flashing the firmware or what have you. Go to the card, go to global right here, click on that. Okay, here we are. So we go to global and look at the global controls. And this is where, again, you can, like we did before, here's another place where you can control some of the features of the external clock, and then your iRig time. There's also a couple of sensors on board, and you can monitor those as well. All right, now another thing that you can do is actually, you can actually program the flash on the device, okay? And that's the flash being what programs the protocol engine. So as we go through and issue new versions or revisions of our firmware, you can actually go and flash the firmware on your board or device without any need of sending it back to the factory. Okay, so that's a very nice feature. Saves a lot of time. Okay, and just makes upgrades a lot easier. If you were to, for example, buy one of our products and did not have all of the options installed on it, like you had a dual function card instead of a full function card, and later on you wanted to go ahead and upgrade to a full function, we could actually sell that to you and email you the file, and you would just go here to program the flash, and you would go ahead and, in fact, hold on a second, let's do this. Let's do all of this here. I want to show you the real thing. Go back, open the board, go back in. Okay, program the flash, and actually just go and load the file. I mean, here it is. It's a bit file right here. If I went ahead and clicked on this guy, it would just overwrite the program that's on that FPGA right now with this protocol engine version right here. Okay, not going to do that this time, but it actually goes pretty quick, and it's not too much of a problem. So programming the flash. But anyway, you could convert your card. You know, say you only had the dual function, not the full function. Okay, you could convert it to the full function, or you could, you know, add the RT-Val software or what have you, just by programming that flash. So we also support arinc 429, and again, as you might have guessed, it's got the little controls for whether you're doing receiving or transmitting or playback. Okay, label importing, channel settings, and so forth. So we also have that available. So thank you very much for your time. I hope that was of some value to you, and feel free to contact Ryan or myself with any questions.
Thanks so much, Bill. Just a couple questions to clarify. How do you use AltaView to see the hardware that you have, or the functionality that you have? What are you using to get that little menu to pop up?
Oh, it's just this little blue circle with the question mark in it.
And that'll always tell you your device configuration and what's enabled in AltaView, and if it's the full function AltaView as well?
Exactly. In fact, what you see right here, the AV means AltaView is enabled. Okay, so if you're just using the free version, which gives you just the monitor function only, it would say no, that AltaView is not enabled.
So the free version would say AltaView enabled to no.
Correct.
Okay, got it. So that enabled is actually the full functionality being enabled.
Correct.
Okay, great. And is there an easy way for customers to look at the feature set differences between the full feature and the free version? Is there an easy way to do that?
Yeah, I believe if you go into the manual for AltaView, here we are, the feature table, Appendix E.
Perfect.
Okay, it's going to show you exactly what is and what is not supported by each version.
Okay, great. So Appendix E in the AltaView User's Manual gives us the feature set for full function, different functions, as well as the AltaView functionality as well.
That's right.
Okay. Got it.
It's a great manual. I mean, it's extremely useful. So
okay, well, I think that's great for today. Thank you for your time, and certainly for everybody watching, feel free to reach out to Alta DT or Vic Myers Associates if we can help you with your next avionics project. We're happy to help out, and we really appreciate your interest in Alta and Vic Myers Associates, and we look forward to seeing you out in the field soon. Thanks so much.